Okay, hello everyone, welcome. Today, I think I am told this is the last session of today here, so thank you for coming. My name is Esra Kayabalı and I am a solutions architect at AWS based in Amsterdam. So I must say I'm thrilled to be here with you today at re:Invent. My first re:Invent was 6 years ago in 2018. I was an AWS customer back then, so I had the opportunity to see all those speakers on stage, attend amazing sessions, and experience one of the biggest IT conferences in the world. And back then, I wish to be on this stage someday. And now, I have the privilege to share the stage with my dear colleague, Velishva Boya. So, think about an imaginary situation where a retailer and a media company might collaborate to understand advertising effectiveness without sharing customer PII. So they can analyze the overlap in their customer bases and campaign performance while maintaining data privacy and security. You wish for a magical room where you can analyze all the information you both have without seeing the raw data. So that's essentially what AWS Clean Rooms does, which will be our topic today. So it helps you collaborate on data insights without revealing the raw data. AWS Clean Rooms turns missed opportunities into aha moments while keeping data secure. So let's dive into this exciting topic together. Today, we'll be exploring 6 key areas. First, we'll discuss the challenges we face when collaborating with data. Then, we will introduce you to AWS Clean Rooms, a game changer in secure data collaboration. After that, we explore some compelling use cases and benefits. In the second half, Velishva will join us to talk about 2 types of analysis you can perform with AWS Clean Rooms. Then we'll show you the capabilities of AWS Clean Rooms in action with a demo. So let's talk about the elephant in the room, data collaboration challenges. How many of you have faced issues when working with shared data sets while trying to protect the raw data? Yes, of course, right? We are dealing with 3 major challenges here. First one is data fragmentation and silos. Our data is scattered across different applications, channels, and partners. It's like trying to complete the puzzle with pieces from different boxes, right? It creates compatibility and scale challenges. The second one is data proliferation. The next 5 years, we'll see more than double the amount of the digital data created since digital storage began. That's mind-boggling, isn't it? That's a significant amount of data. And companies need to understand how they are driving business outcomes using that data. Finally, evolving data landscape. We are constantly trying to balance data utilization with privacy concerns in this ever-changing environment. We need a better way to manage how our sensitive raw data is collected, stored, and used while also being sure to data privacy. Let's take a step back and define data collaboration. Data collaboration is a process where 2 or more organizations can securely share and analyze data while maintaining control over sensitive information, protecting customer privacy. It enables organizations to drive insights from combined data sets without actually exposing or sharing the raw data with each other. Now, here is where it gets tricky. Traditional data collaboration methods often feel like choosing between a rock and a hard place. You either share your raw data and hope for the best, or you don't collaborate at all and miss out on valuable insights. So you want to limit data movement as much as possible in order to protect your data, prevent misusage, and avoid risk of leakage. It's like being asked to lend your diary to a friend and you want to help, but you're not sure that you want them reading everything. So the result, many of us choose not to collaborate and potentially missing out all of the game-changing opportunities. But what if I told you there's a better way? Enter AWS Clean Rooms. Just like I told you in the beginning, imagine a magical room where you and your peers can analyze collective data sets without revealing the underlying data. Sounds good, right? So, while with AWS Clean Rooms, you can create this secure environment in minutes and start collaborating with anyone on AWS Cloud to generate unique insights about a range of use cases. So, many of you want to securely share data with selected partners, and AWS Clean Rooms helps you analyze data with business partners without sharing your entire data set. This capability allows you to safely analyze collective data and generate insights that couldn't be produced independently. However, our customers expressed a desire to do more than analytics. They want to apply machine learning to gain predictive insights within their clean room. And one way to accomplish this is through lookalike models, which using a small sample of customer records to expand to a set of similar records with a partner while securing and protecting your data. For example, imagine an airline that can analyze signals from its loyal customers, collaborate with an online booking service to offer promotions to new but very similar users. So until now, this process has been extremely difficult to accomplish without one party sharing data with the other, right? This is where AWS Clean Rooms truly shines. So it addresses this critical need by providing a secure and efficient solution to collaborate and do data analytics and insights generation. Let's explore some use cases, shall we? First one is enhanced customer insights. So creating a comprehensive view of customers by combining data from multiple sources, like digital behavior, purchases, partner data, or channel interactions. To better understand the preferences and patterns of your customers. This enables smarter decision-making and improved customer experiences through strategies and personalization. Second one is optimized marketing and advertising experiences. Partnering with media and advertising companies to enhance campaign effectiveness by sharing relevant data assets. So this enables precise audience targeting, real-time campaign optimization, and accurate return of investment measurements while delivering personalized experiences that resonate with your consumers, and all while protecting the customer privacy. Third one is improved reporting and measurement. So leveraging cross-organizational data collaboration to gain deeper business insights while maintaining data privacy. This enables accurate performance management, measurement, trend forecasting, and risk assessment through secure analysis of combined data sets from multiple business units or partner organizations leading to more informed strategic decisions. Finally, accelerated research and development. Fast-track product and technology innovation by securely pooling expertise and data across organizations. And this collaborative approach leads to faster market validation, reduced research costs, and more efficient development cycles while protecting each other's intellectual property and sensitive information. So, now, you might be thinking, this sounds great, okay, but isn't it complicated? So here is the beauty of AWS Clean Rooms. It's easy to set up. So you can create a clean room in minutes using the AWS Management Console, and the process just takes just a few clicks, right? For those who prefer programmatic access, AWS Clean Rooms offers a comprehensive API, and with this API, with just a few API calls, you can create and manage clean rooms programmatically. Other solutions require you to repeatedly have to copy and upload your data in storage environments that are out of your control or outside of your control in order to collaborate. With AWS Clean Rooms, your data stays put. You don't have to move it, you don't need to upload it to external environments. And you can quickly connect your existing AWS data sources to the clean room, just like S3 buckets. And just this Monday, we launched another data source, Snowflake, and Athena. You can use that to connect to your existing data sources. And you are in control here. AWS Clean Rooms provides a broad set of configurable data access controls, like including query controls, query output restrictions, and query logging. That allows you to customize query restrictions run by each clean room participant. And it's flexible. You can use built-in analysis rules to tailor your queries to your specific business needs, right? You can also use AWS Entity Resolution capabilities for AWS Clean Room to prepare and match related records to help improve data across collective data sets. So now I'd like to call Verishva here, and let's hear from Verishva how to get started with AWS Clean Rooms.
Thank you, Ezra. Hi, everyone. So we've been hearing that you can actually use this tool to set up a collaboration. So now we're going to look and see what that actually looks like. And we will look at a demo that we will set up using the AWS console. Before we dive into the demo, though, I'd like to do a recap of a few concepts. We talk about the fact that with AWS Clean Rooms, you always have control. But what does this control look like? There are a couple of analysis rules that you get to define. Analysis rules are restrictions that give you built-in control of how your data can be analyzed. Once we go into the demo and we see the collaboration being set up and members actually joining the collaboration, we'll see how they get to have control of what happens to their data throughout. And they're doing this by using analysis rules. Collaboration members who create or who join a collaboration as a designated query runner then get to run these queries based on what the rules have been defined, on how these rules have been defined. AWS Clean Rooms controls support 3 types of analysis rules: the aggregation analysis rules, the list, and the custom. So what does an aggregation analysis rule looks like? With an aggregation analysis rule, this allows you to run queries that generate aggregate statistics. These could be statistics where you're looking at how large is an intersection of 2 data sets. So when you are using an aggregation analysis rule, You can enforce rules such as specific parts of queries that you get to say what kind of a function can be run against this type of data. The next analysis rule that we have is a list analysis rule. With a list analysis rule, this one allows you to run queries that extract row-level list of the intersection of multiple data sets. Again, you're looking at an overlap of 2 data sets, and then the last one that we're going to look at is the custom analysis rule. And with a custom analysis rule, this allows you to create custom queries where you are using most of ANSYS standard SQL, such as common table expressions and window functions, as well as review and allow queries before collaboration partners can actually run them. So with this one, you get to have a lot more control. You do check-ins all the time before any queries can be run against your data. Now let's look at the demos and we see what this setup actually looks like. So there are 3 steps that you follow when you are setting up a collaboration for on AWS Clean Rooms. You start by creating a collaboration, you then add members to the collaboration, and then you run queries to gain insights. When we're looking at the creation of the collaboration, we're going to look at how the collaboration actually gets set up and how members get added to the collaboration. And then once a member has been invited to the collaboration, we'll see how they actually accept that invite and add themselves to the collaboration. And then we'll look at how a query then gets run and what we actually get to see. Before we start, talking about an example of a use case, I know Ezra ran us through a few use cases that you can consider, but the demo that we're going to look at is still a collaboration, but it's a different use case. Now ask who in the room belongs to a community, let's say a tech community or a running club or some form of a community. We do, right? And who belongs to more than one community, right? And especially during the lockdowns, especially in the tech community, we saw people joining more than one community all of a sudden. So the use case that we're going to look at, it is a hypothetical leader of a Java user group, tech community. They want to collaborate with the Python user group. What they want to do is, if it turns out that both of them have got some members in common, they want to collaborate to host the next tech event. It only makes sense if there's some overlap. So that's happening here. The Java user group is the main collaborator. They're the ones who are setting up the collaboration and inviting the Python to collaborate. And just so we can keep track as we go through the demo, remember we're going to look at 2 separate AWS accounts. The Java user group, which is the main one, is the dark mode, and the Python is the light mode, just so we keep track as we go through the demo. So now let's start. So the very first thing that happens is that in the account of the Java user group, in AWS Clean Rooms console, they start to create the collaboration. And they do this by defining some elements of a collaboration. And these are elements such as, what is the name of the collaboration? What is the description of the collaboration? They also define the analysis engine that will be used in the analysis or the query later on. And here you've got an option of either going with Spark or you use AWS Clean Rooms SQL, which is what we will use for this example that we look at. They then add members to the collaboration. They're the first member they're going to add, and then they will add the member that they're inviting. And just a reminder, Clean Rooms, you can have up to 5 collaborations, but here we only just have 2. So they add the second member they're inviting, and they add their AWS account ID, and then they proceed to define other elements such as the query. Every time it runs, is it going to be logged? And also, who will be running the query? Only one person is allowed to run the query. So we define this when we define the collaboration. They also define who will receive the results of the collaboration. And lastly, they define who will pay for running the queries. And this time they've selected themselves. They also define a location which has to be an S3 bucket where the results of the analysis will be written to. And we're selecting an S3 bucket for that. And this is not a special S3 bucket. It's just a plain normal S3 bucket that was defined. They define whether they want to log every time a query runs, CloudWatch logs, and then they finalize the creation of the collaboration. So once they've checked everything, we can see they're now creating that, and there's the same time that they're creating the collaboration, they're adding themselves as members to the collaboration. So that's the first step done. We've created a collaboration and we've invited the second person, which is the Python user group, to become a member of the collaboration. Now we're hopping on over to the account of the Python user group, and when we go onto the AWS Clean Rooms console, we see that they've got an invite to join a collaboration. So to join the collaboration, they go through creation of a membership of that collaboration. And the same, creating that, they also want to be able to store logs every time that query runs. And we said when we created the collaboration that both members need to receive results of the queries. So here they're defining that on their account, that's where they want the queries to be, the results to be stored. And they define and they create a service role that will be storing those results. And then they finalize the creation of the membership. So now they are a member of the collaboration that invited them. So the next step, we said, with clean rooms and the collaborations, you are bringing your own data to the collaboration. And now what does that look like? How is that going to look? The next step, we now configure a table. We're now a member of the collaboration. So we're going to create a configure table. A configure table maps how we can find against the underlying data. So for the purposes of this demo, we're going to select data that is already stored in Amazon S3. Earlier on that we have other sources that we could have selected. But here we're going to use the Amazon S3, and this data is already cataloged in the AWS Glue catalog. We're viewing the schema just to see what it looks like, but you'll see later on, we still have control to select which columns from our table we want to bring into the collaboration. So we just select just the ones we want to bring across. We leave the name out because we don't want to expose this to the collaboration. And we finalize the configuration of the new table. So now we've configured the table. We are going to the next part where we define controls. We want to say how our data actually will be analyzed. Doing this, we now define an analysis rule. Earlier on, we talked about the 3 types of analysis rules: the aggregate, the list, and the custom. For this demo, we are selecting the aggregation. And with the aggregation rule, we're doing this because we want to know the percent overlap between the 2 data sets that we have. So we're specifying aggregate, and we say which column is going to be this it will apply to. We define the functions that we're going to use against this column, and for this we are selecting the count and the count distinct, and against the ID. We can see there that there are other functions that we could select, but we don't need them for this demo, so we leave these alone, and we move on to define joins. So we could have not defined joins, but we're going to define joins here, and we're defining joins to say we're joining on the hashed email and the hashed phone. So we already selected to bring this to the collaboration. Now we define them for joins, and we move on to define optional dimension controls. What we do with the optional dimension controls, this says that this defines that we want the data to be filtered, grouped, or aggregated, and we'll say what field we want it grouped or aggregated against, and then we define the aggregation constraints. With aggregation constraints, we are protecting the data, so we say which fields we want to make sure that never get brought across onto the collaboration. And then we finalize this. So we configure the analysis rule. So this is the control that we have. We've now said, as the Python user group, this is how we want our data to be analyzed. Once we've done that, we then associate the table to the collaboration. So this is the collaboration that we were added to earlier on. And when we associate the table to the collaboration, we define a few elements, such as just more details about the table, and we also will create a new service role. With the service role gives AWS Clean Rooms permission to read the underlying S3 and then to also read the table. And we continue with that, and we finalize the configuration of this analysis rule. Once we are done with this part of the process, we now will have a table that is ready to be queried in the collaboration. If we click out of here and we go back to the collaboration on the left, and we click and we go to the table tab, we will see that this table is now all here and it is ready to be queried. We just click and we selected the collaboration again, and we go to the tables tab, and we can see the table is now ready. So we're done with everything that we need to do on the side of the Python user groups account. So we hop back onto the account of the Java user group. We're going to finalize a few definitions before we're ready to run the query. So with the Java user groups account as well, we also want to configure a new table. Again, we define the source of the data that we'll be using, and it's still going to be Amazon S3. We already have a database, and the table is already cataloged in AWS Glue catalog. Looking at the schema, we've got a lot more columns, but we only want to bring a few across. Again, going with the concept of least privilege, talking about those controls and protecting your data the entire time. So here we're only selecting hashed email, hashed phone, and these are the only columns that we want to bring across. I know that I said earlier on that a lot of the queries we're going to be running them against the Python table, but the Java user group might want to run some queries against their table as well, and this is why we are doing this part of the process as well. Now that we have completed to bring the data across and define what columns to bring onto the collaboration, we move on to the next part, where we are defining the analysis rule as well for the Java user table. And doing that, again, we're selecting the aggregate analysis rule, and then we define other elements as well. So here, it is different, it's the same functions, but against different columns, because for the Java table, we're only bringing across the hashed email and the hashed phone. So we might want to do some analysis against them, and that's why we're bringing them here. And we continue to define other elements, such as what the joins will look like, what dimension controls we will have. We will again skip the scalar functions, and we'll continue to finalize this by defining the aggregation constraints as well. So same process that we saw on the other side. So we're done. The analysis rule has been defined, and it's been configured. So now both accounts have got analysis rules defined. Now the last step is to associate this table to the collaboration as well. So same process that we did in the Python user groups account, we're doing this side as well. We are configuring and then we're associating the table to the collaboration. A few elements also get defined, such as the service role, which gives AWS Clean Rooms access to read the underlying S3 and the tables in Glue. We finalize the configuration so that on this side as well, the table can now be ready to be read and queried. This definition here is saying who will receive the results of the query. And in this case, we're saying both members of the collaboration will receive. We could have just chosen just one, but we're saying both of them will. At this point, if we go to verify, we go to look at the collaboration, we'll see now both tables from both accounts are ready to be queried. So now that we've done all the definitions, let's start running the query to see what we actually will see and what it actually means. So the last step is to run the query. So we're now continuing in the account of the Java user group, because when we define the collaboration, we said that they are the people that will have access to run the query. So they're the only ones who can run this query. So let's start running queries and see what we get. So we're starting with a simple select star query, and we should get an error. We're getting an error because we defined specific columns that we want to use. So that control and protection of your data. We try again, but this time we're not defining joins. And we should get an error because we said this can only be run with joins. So again, seeing that that control is still there and the protection of how your data is queried. Last time we're trying, and now we've got the correct column and we've got the correct joins, which is hashed email was defined as one of the joins. And the query this time actually runs and it completes, and we see we're getting a number because what we're looking for is an aggregation. So an aggregate number is all we're looking for. And we'll see that the query ran successfully. And what all of this means is that based on what they're seeing as these two communities, they could then say, okay, looking at the numbers, it looks like we have enough people on both sides that justify us collaborating on an event. This demo was run with a very small subset of records, so, but as a real-life user group or tech community, you would have a lot more numbers than this, and based on that, you could then make decisions on how you want to proceed. So, we've just seen an introduction to AWS Clean Rooms, and we learned how to create an AWS Clean Rooms collaboration, how to add members to it, how to run queries to gain insights about overlap analysis. No data was brought across from any of the collaborators with all of this. How do you get started with AWS Clean Rooms? So to quickly get started with AWS Clean Rooms, you can start with one priority use case where you have a few priority partners that you partner with to quickly evaluate the value of collaborating with them. What we just saw was a small subset of data. So based on that, you could decide if you want to proceed. So you can determine which partners you want to collaborate with, which use case you want to test, and what success criteria is for the AWS Clean Rooms collaboration. With the query that we saw running, we only got 17. I know it was a test. Based on the numbers you are seeing, you can decide if you want to proceed and actually do a collaboration together. So this way, you get to collaborate before you decide if you want to invest in adopting, automating, and scaling your data clean rooms collaborations. So the next step that you could then move to is the technical choice to analyze in a collaboration. So you can define who will set up the AWS Clean Rooms. The demo that we looked at, the Java user group was setting up the collaboration. They were the ones running the queries. They were the ones paying for the queries. But when you do your planning, you could decide who gets, how you split all that responsibility. So once you create a collaboration, you can then configure your SQL or your ML parameters for collaborating with your partners. And after you've run a collaboration, you can evaluate insights and how the outcome outlines to your success criteria. So to learn more, you can scan that QR code. You will then take you to the site of AWS Clean Rooms, and you can learn more there. We thank you for making the time to come out. And we ask you to please consider completing the session survey in the app. It is the only way we improve and know how to do better for you. So we will appreciate your feedback very much. Thank you again for your time.